Hello, happy Monday, happy March. Oh my goodness, we're here. We're already to the third month of the year. I hope you are doing well. I hope you had a wonderful weekend with whatever you had in store. We got rained out from Little League opening day here in our household. And so we had an unexpected afternoon and morning to spend with one another, and it was good. It was rejuvenating, and so I am hoping the same for you, that you could have that this past weekend, and that the week is starting off okay, and that things are going well. I wanted to jump in today to chat with you about a question that came up as I was working with some teachers from school district up in Oregon last week, and it just had me sort of thinking and noodling on a bunch of things, which is so we were talking about, sorry, let me go back. We were talking about patterns and how we can help our students describe and analyze patterns, and where are they at when they're looking at a graph or a map or a data visualization versus where we want them to be when they are looking at those things. And so we were talking through the like, when we look, when we're presenting our students with a data visualization and we're asking them to see the pattern in the visualization, we were talking about kind of breaking it down into the 5 common patterns that we often see in the K to 12 space, like I talk about in a bunch of our programming. And then they had gone out and had their students look at some visualizations, look at some graphs. These were mostly middle school science and math classrooms that the students that they were reporting back from. And some folks were sharing that some of their students we were trying to ask them, like, what common patterns do you see? Increasing, decreasing, stable, cyclical, things like that. They were saying they noticed that it was orange, or that there were dots. And we had a little commiseration session and jam session as well on the like, that's really helpful information to know. If we are trying, we'd already taken it a step back to go to the 5 common patterns. And if we had, but we're trying to get them to understand what that pattern means in the context of the broader thing that we were talking about, right? So we felt like we'd already taken this step back to be like, pause. Do they know the common patterns? And what we were hearing from some of their students is that they were still at the aesthetics. They were even a step further back, and they were on the color of what was showing up in the visualization. So that was one moment of a like, it is really helpful to help get our students to make their thinking visible, because those students might not be missing the data interpretation questions because they don't understand your content. To me, what that is a flag of is they don't understand how to look at the data visualization. They don't know what to look for, what to pay attention to, things like that. And that relates to this other piece that I wanted to chat with you all about and hear your comments and thoughts on like how this goes for you and your students, because a teacher shared that she was having her students work with a data set. Here, wait, I've sort of like somewhat recreated the data set based on my memory. And so this is not like an actual data set or lesson that they were using, but this kind of can get at it. So in essence, in the lesson, what she was doing is she was having her students, or the lesson included data on the students were provided values at 2 different points in time. Let's say like 1990 and 2000, something like that. And then they were being asked to like, what is the pattern? What is the trend, right? We were talking about patterns, what's going on. And then the next step was like, well, and then what do you think it might have been in 1980 or in 2010 or in 2020? And this teacher brought up the real challenge of that. First there were some students that were struggling to see that this was a decreasing trend, that the extent of whatever they were looking at dropped from 1990 to 2000. Okay, so that is bucket 1, or maybe bucket 2. Bucket 1 is like they're looking beyond colors. Bucket 2 is that if our students are having trouble seeing this as decreasing, that's an indication that they don't know that pattern of decreasing. We're trying to, in essence, ask them to read Harry Potter, and they don't yet know, they can't yet read Dr. Seuss type of thing. And so we need to help them understand that pattern and what this means, that as time increases, as we went from 1990 to 2000, the extent of whatever this we were looking at decreased over that time. It went down. One variable is going up, year is going up, the other variable went down. But this second layer of, okay, so being able to look at this, now can we extrapolate out beyond where we have data points? Is cognitively, there's a lot going on in that. I'll stop screen sharing for a second. In that, we need our students to be able to understand that that line indicates what the extent would have been if we had recorded data values, if we had points, dots, as were indicated on that visualization for those points in times between the decades. Okay, so that line in and of itself on our line charts is an extrapolation of sorts. It is a estimation of, had we gone out and collected data, it is likely that the data value would have been somewhere on that line. So it's not just we're connecting the points. That line means something about our data. And why am I stressing that? Because that is huge. Let me bring it back up again. That is huge for understanding. Therefore, this is not actually recorded values. Our recorded values are the circles, the two circles here. But that's our estimate based on these two data points. And we can use that as information to think about, okay, well, so what do we think based on this? Would it go down? Would it go up? Would it stay the same? And we can then get into the nuanced conversation of, what do we think? Where might that pivot? And this is where I'm going to say annotations are your friends in helping our students start thinking about that extrapolation. So, one, understanding that the line in and of itself is in essence an extrapolation. It is based on our, it is an indication based on our data where we think the data values would have been. That's step one. And then step two, how can we help them extract out? And this is where it slightly drives me crazy because I can't figure out how to like easily add a line in. If you know, please share. I would love to know. Drop it in the comments or reach out on however you want to reach out, support@dataspire.org or wherever. Would love to hear how you are getting your students working on this. I'm just going to pull this up in a different window. This is numbers. Excel also lets you do this, things like that. So same data set. It looks a little bit different because this is numbers orientation as opposed to we were just looking at Google Sheets as we were going through. And this line that I just moved, so I just added this as in I went to a shape, I added the line, and then I moved it around. And so I can move this around. I can extend it out so that it goes past the 2020 and it goes into, it connects in to the y-axis for 1980. So then I've got my two pieces. I can change here the stroke so that it's not a constant, but it's a dotted line. All of these things we can do in Excel as well. All of these things we can do with the drawing overlay in Google Sheets. I just find the drawing overlay is sometimes like a little clunky and that's a little tricky for me. But why am I spending all this time? Having our students draw this line out can be really helpful for them to think of the line between the points as just one small part of a longer line that we could draw. And this can also help them think about, oh, well, does this make more sense? Or do we think that it would be, it would go like this or this or this or this or this? So all of these different options from 2000 to 2010 and using active annotations on the visualization. So if you're in a graphing program, we can use what's there in the graphing program to add those annotations in. If it's on paper, great, grab a ruler. Clear rulers are especially helpful for this to think about that. Now, this is just one tip when we're working with a time series and we've got a line graph and we're trying to help them sort of extrapolate out, but just wanted to call out like one, that's a great tip. It's an active engagement strategy. It provides a visual component, it provides a kinesthetic component of it, of making sense of static, what can sometimes feel like static data. And two, the like, and this might be a helpful step to get your students to where they're going. So, just some thoughts for this morning or this afternoon, wherever we are on our Monday. I've totally lost track of time. I hope you are doing well. As I say, if you have ideas on how to add annotations better to Google Sheets, please share them with me. And how do your students do with this extrapolating out from data and thinking about, okay, so we have some data and then how do we extrapolate out? What are some strategies that you found that really resonate with your students? That's it for now. Have a great week. See you all.